Hello students, now we are going to discuss very important topic, that is stress block parameters. It is not only important for the university examination, even in the GATE exam and engineering services also they are asking for 10 marks. So put triple star, stress block parameters. In IES, they are asking for 10 marks, so put triple star. Before we are entering into the derivation of the stress block parameters, first we should learn the Euler-Bernoulli assumptions. So, in the first assumption, what Euler-Bernoulli said in the first assumption? Plane section. If you see the section of this member, you treat it as a member, it is looking like a rectangle. So it is a plane now before loading. Now I am applying some load at the middle. So I am applying some load at the middle, then what happens? The member will try to bend like this. Means there is a deflection is occurring here in practically. But what Euler-Bernoulli said, even after loading also the member will be bending, but you consider it as a plane. So that is the first assumption. Plane section remains plane even after bending also. So then only this derivation can able to do it. The next assumption is the ultimate stress strain in concrete is 0.0035. So next, before entering into this derivation, Jai Balu, then Balu will enter, take one hexa blade and cut the beam and chudu. Okkavaipe chudu, either left chudu or right chudu. If you are cutting the beam and chudu, then what you will see? There is a cross section like this. There is a cross section like this, having a neutral axis. Above the neutral axis, this is called compression zone, and below the neutral axis, this is called tension zone. So we know for compression, who will take care? Concrete will take care of the compression, and in the tension zone, who will take care of the tension? Steel will take care of the tension. So this is called area of tension reinforcement. Is nothing but area of steel. Next one is, this is the width of the beam. This is width of the beam, and this is center of the tension reinforcement to the outermost compression fiber. This is called effective depth of the beam. And also if you see this one also, this is the effective cover C dash. From the center of the tension reinforcement to the outermost tension fiber, the distance we call it as a effective cover of the beam. If you need total depth of the beam, that is the summation of effective depth plus effective cover, then you will get the total depth, that is capital D. So now next one is strain distribution. In one time there was asked in GATE, what is the strain distribution shape, the distribution curve, what is the shape? Linear. So one time there was asked in GATE for 1 mark, the distribution of the strain in the stress block is linear. Next one is the ultimate strain in compression. What is the ultimate compression in 0.0035. So next, stress block. Before we are going to stress block, stress block, we know that there is a stress strain curve for concrete. There is a stress strain curve for concrete. In the y-axis we are having stress, in the x-axis we are having strain. Concrete is brittle material, it won't give any warnings, it will take the load and it will fail suddenly. So what happens? It will take the load and it will fail. What is the ultimate strain for this concrete is 0.0035. Even Url Berne assumption also, he said that the ultimate strain in concrete 0.0035. What is the stress? Ultimate stress FCK. Theoretically FCK. Now we will apply slenderness effect. See, in the laboratory when you are going to test the cube, you are taking sieved coarse aggregate, sieved fine aggregate, even water also, mineral water also sometimes you will consider. But what happens? You will thoroughly mix it, even casting also you will carefully do it, even in the curing also you will do properly. But whereas coming to the field, it is not possible at all. There is no sieving of coarse aggregate, there is no sieving of fine aggregate, even water also, whatever the water is available, that water we will mix it and we will do the concreting. So what happens? Whatever the care you are taking in the laboratory, the same care you are not taking in the field. So that what happens? Concrete is a heterogeneous material, so that they are having different properties. Whatever the strength you are getting in the laboratory, the same strength you did not expect in the field, so that you will apply some ladies reservation. So what is the ladies reservation? 33% ladies reservation. So we assume that there is a 33% reduction of strength in the field. So if you are applying that 33% less, then what is the strength you are considering? 0.67 FCK. Not only that, we have partial safety factor, means civil engineer can underestimate the strength and overestimate the load. That is the agenda for us. So now what you will apply? Safety factor, partial safety factor. What is the partial safety factor for concrete? 1.5. So once again further you will apply, then this 0.67 FCK divided by 1.5, then what is the value? 0.446 FCK is nothing but theoretically in the laboratory when you are testing any member, it will give 100% strength, but practically you are considering only 44.6%, not even 50% of the strength you are not considering in the field, means you are underestimating the strength of almost 55.4%. You are underestimating, only you are considering the strength as 44.6%. It is nothing but, for example, I am having a carrying capacity of 100 kg. I can able to carry 100 kg. If you are putting any weight, I will carry 100 kg. But you are assuming that he can able to carry only 44.6 kg. You are neglecting 55.4%. But I can able to carry. But you are underestimating the strength. So that what happens? Even if the load is increasing, there is no problem for the member. So that's why the members are stable. So now tell me, so using this curve, if you see this curve, what happens up to this portion? It is a parabola. After this, this is a straight line. So same thing I am applying here. Same thing I am applying here. This is up to here something, this is rectangle, afterwards this is parabola. Okay. So at this, what is the strain we are having? At here the strain of 0.0035, what is the stress developed? 0.446 Fck. So this much of the stress developed at a strain of 0.0035. Next, one more thing is, when you are doing this parabola curve, this parabola is at up to at a strain of 0.002. This strain is at a strain of 0.002 and this is a strain of 0.0035. Now tell me, at this strain the curve will be having parabola up to this limit. Afterwards, this is a rectangular block. Now what I am doing is, if you see the stress block, it is not a rectangle, it is not a completely parabola. So up to certain point it is a parabola, afterwards it is a rectangle, so that I am dividing into two parts, 1 and 2. So it is above the neutral axis, means compression zone, so that which force is acting? Compressive force will act. Compressive force will act. Below the neutral axis, which force will act? Tensile force will act, because already we discussed, above the neutral axis compression will develop and below the neutral axis tension will develop. Now we know that this is the depth of the neutral axis xu, depth of the neutral axis xu, but I won't consider complete xu because it is parabola and rectangle. Now I am assuming this depth as x1 and this depth as x2. We know total depth xu, but we want to find out what is x1 and what is x2 by using similar triangles of strain. We know already the values of strain, 0.002 up to x1 and total xu 0.0035. Okay, so by using that similar triangles, using similar triangles of strain, this is 0.0035 strain, this is 0.002, the overall, this is x2, this is x1, total xu. Now using similar triangles of strain, what will do? For this much of strain, similar triangles of strain, for this much of strain is nothing but 0.0035 at a depth of xu. For strain of 0.002, what is the depth? x1 is nothing but divided by x1. Now our aim is to find out this x1. What we should do? We will do the cross multiplication. Now x1 equals to 0.002 divided by 0.0035 into xu. By using simplification, x1 equals to 4 by 7 xu. x1 equals to 4 by 7 xu. Now x1 already we determined. What you should determine? x2. If you want x2, xu equals to x1 plus x2. You want x2, what you should do? xu minus x1. So xu minus x1, if you apply, what happens? If you apply xu minus Now x2 equals to xu minus x1. x2 equals to xu minus x1 is 4 by 7 xu. Take LCM. What happens? x2 equals to 7 xu minus 4 xu divided by 7. Therefore, x2 equals to 3 by 7 xu. Even without calculating also we can find out how out of 7 parts 4 parts are x1 means what about remaining 3 parts. So therefore x1 equals to 4 by 7 xu and x2 equals to 3 by 7 xu. Put it in dabba. Okay. So we determine the depths. Now we want to find out what is the total compressive force. What is the total compressive force is acting and what is the total tensile force is acting to moment of resistance. Now again I am drawing this stress block as this is stress block having a stress of 0.446 FCK and already up to parabola this is x1. x1 means 4 by 7 xu and this is 3 by 7 xu and there is a compressive force C is acting. We don't know where it is acting, in the rectangular portion or parabola portion. Part 1, part 2 is nothing but the entire compressive force I am dividing into 2 parts. One is for rectangular portion how much the compressive force is acting, for this parabola portion how much the compressive force is acting, that I am assuming C1 and C2. Total compressive force C equals to C1 plus C2. We know that stress equals to force per unit area. You want force. If you want force, what you should do? Cross multiplication you should apply. Force equals to stress into area. Stress into area. Which stress? Either it may be compressive stress or it may be tensile stress depending upon the force. If you want compressive force, compressive stress into that area of that compressive zone. If you want tensile force, tensile stress into area of that tension zone. Okay, means is nothing but area of steel, because steel will take care of the tension, so that you will use area of the steel. Now our aim is to find out the compressive force in 2 parts. One is part 1 C1 and C2. Now C1 compressive force is equals to which stress? Compressive stress is nothing but this stress 0.446 FCK is nothing but average stress in 1 into A1 is nothing but this portion. C2 equals to average stress in 2 into A2 means this portion, parabola portion. Okay, area of this parabola and average stress. What is here also the average stress? This is the average stress here also, because this stress is not only for this rectangular portion, same stress is acting on this parabola portion also. Okay, so now I am going to find out first C1. C1 equals to average stress 0.446 446 FCK into what is the area of block 1? This is the area of block 1. What is this shape? Rectangle. What are the dimensions of this rectangle? Width, depth. What is the width? This is not the width. This is the stress. How we can say this is a stress? Based on the units. If you see this FCK, FCK is nothing but characteristic compressive strength of the concrete that is having strength. Strength is nothing but what is the units of strength? Newton per mm square. So we need width. What width we should use? Beam width. What is the width of the beam? B. So B into what is the depth? 3/7 XU for rectangular block. So just simplify, you apply the simplification. Similarly for C2. What is the average stress? The same stress here also. 0.446 FCK into width, same width, width of the beam, B into 2/3 of what is the depth? 4/7 XU. Now what we should do? We know individual C1 and C2. Now we should find out the resultant, means total compressive force. Total compressive force C equals to C1 plus C2. Add these two things, finally we will get 0.446 FCK into B into 3/7 XU plus what is C2? 0.446 FCK into 2/3 into 4/7 B XU. Do the simplification, finally we will get the total compressive force C equals to 0.36 FCK into B XU. Put it in dabba. This is the total compressive force. See, sir, whether my compressive force what I determined that may be right or wrong, how I can cross check it? Very simple. See, compressive force, what is the units of force? Newton normally. What is the units of, this is a numerical value, there is no unit for this. Coming to this FCK, FCK is nothing but characteristic compressive strength of concrete, is nothing but Newton per mm square. B is nothing but width of the beam, width unit we are using mm. XU is nothing but neutral axis depth. What is the unit of depth? mm. mm will cancel. Here also mm will cancel. So what is the finally? Newton. So in this way we can cross check it whether these values are we are reducing or we are increasing. So based on this we can cross check it. This is the total compressive force acting on that stress block. Okay. But one more thing is, see where this resultant compressive force is acting. It is total rectangular means so that it is acting in middle. If it is total parabola means it may be acting 3/8 times from the top or 5/8 times from the bottom. But here half of the portion is rectangle and half of the portion is parabola. So what we will do, we will find out the centroid. So what we should do? Assuming that C1 is acting at a depth of y1 and C2 is acting at a depth of Y2 from the compressive fiber, and C we need this one only. This is I am taking Y bar. Okay, now our dimensions also will change, because this C1 is acting center of this rectangle, so that this 3/7 or x2 will be divided into x2 by 2. This is also x2 by 2. Coming to this parabola, where is this centroid will act? 3/8 times x1, and this portion will be 5/8 times x1. Find out the centroid. Y bar equals to C1 y1 plus C2 y2 divided by C1 plus C2. Already we determined C1 and C2, there is no problem at all. Come to y1 and y2. How to find out this y1 and y2? Y1 centroid of this rectangle. Where the centroid will lies for rectangle? Half of the portion is nothing but y1 equals to half of what? x2 by 2. Already x2 we know, 1/2 into 3/7 xu. Similarly for y2, where it is acting? From the parabola acting is nothing but it is taking by rectangle plus this portion. What is this depth of the rectangle? x2 by 2 plus x2 by 2, total x2 plus where? 3/8 xu. y2 equals to x2 plus 3/8 xu is nothing but y2 equals to what is x2? 3/7 xu plus 3/8 xu. Substitute all the parameters in this formula, and finally you will get y bar means 0.42 xu. Where this y bar will act? At a depth of 0.42 xu is nothing but this y bar equals to 0.42 xu. Why we are determining this xu and all? I will show the diagram. So we determine the compressive force also, where this compressive force is also acting exactly we are determining. Now I am drawing the same stress block. This is the stress block, means our resultant compressive force is acting at a depth of 0.42 xu. This is our resultant compressive force from the outermost compressive fiber to the, what is that? This resultant means our resultant force is acting this much of depth. So this compressive force is over. Next, coming to the tensile force. How this tensile force will be determined? If you see, this compressive force is acting here. Coming to the tensile force, this compressive force and tensile force is opposite to each other. Why it is opposite to each other means, the moment developed in concrete and the moment developed in steel, both will opposite act each other, because it will offer resistance. See, let us take, I am pulling this one. I am pulling this one. If I am applying resistance here, what happens? It won't go outside. Same thing here also, if the member will be stable means when there is a force is acting in the other direction, the opposite force is also acting this direction, then only the member will be stable. See, this compression will act like this and this tension will act this direction. So the distance between this tension and compression is called lever arm. The distance between the compression, resultant compression and the resultant tension, this distance we call the lever arm of that member. So compression is over. Now my aim is to find out this tensile force. Very simple. Compressive force, it will take lot of time. Coming to the tensile force, it is very simple. So tensile force T equals to same formula, stress equals to force per area. You need force. Which force? Tensile force. If you need tensile force, same thing you will apply. Force equals to stress into area. Now I need tensile force. Which stress I apply? I apply the stress, the design stress developed in the steel. How I should know the design stress? You know the stress strain curve of mild steel. If you see the stress strain curve, initially it is Fy. After applying the partial safety factor, what is the design stress? 0.87 Fy. How I am applying this partial safety factor? How I am applying this partial safety factor? 1.15. Now my design stress is 0.87 Fy. This much of stress only I am considering. Practically it is giving 100%, but my steel strength in practically I am considering only 18.7%, 13% I am neglecting. Same example in the concrete what I applied. If you see the comparison, concrete only I am considering 44.6% as strength, whereas coming to steel I am considering 87% as my strength. Why, sir? Why? What happening? Why you are neglecting more strength in concrete compared to the steel? Because steel having 10 times more capable of concrete strength. And also when coming to the steel, if you take small specimen or large specimen, if you test it, the results won't change. But whereas coming to the concrete, if you consider a small specimen, if you are getting more strength, and if you are considering a large specimen, you will get less strength. So that's why steel I am considering more strength. So the design strength, stress or strength 0.87 Fy. What is the area? Which area? In the tension zone, who will take care in the tension zone? Steel will take care. So that which area we should use? Only steel area only we should use. We don't use the entire portion. In the tension zone also the concrete is available, but we won't consider that concrete. Sir, you are not considering the concrete strength, then why should you provide the concrete in tension zone? Means without concrete only steel rods, there is no bond between concrete and steel. So it is the bonding purpose mainly we will use the concrete in tension zone also. So but for the coming to the design purpose, we will use the strength only steel strength, not for the concrete strength. Now this is AST. That's it. So T, total tensile force, is equals to 0.87 Fy. This is design stress developed and into area of that steel. So put it in dabba. Put it in dabba. So now this tensile force, again if you want to know the whether this is right or wrong, your determination is T. What is the units? Force, Newton. Now this is a numerical value, there is no unit at all. Coming to this Fy is nothing but yield strength of steel. Yield strength of steel is nothing but, what is the unit we should use? Yield strength, Newton per mm square. Strength, stress, all are having the same unit, Newton per mm square. Area, any area, units is mm square or centimeter square or meter square, but we are considering here mm, so that here mm square. Now mm square will cancel. What is the remaining? Force, Newton. So like that we will find out the compressive force and tensile force. Next one is, after seeing this diagram, you should understand why we are finding these things. Why we are finding these things. So now there is a box, there is a beam. Already we know that this is the neutral axis, and here what happens? Tension will develop in the tension zone, and there is a compression will develop in compression zone. And this distance between this compression and tension zone, what is this? Lever arm. How to find out this lever arm? We know that here from the outermost compression fiber to the center of this tension reinforcement, this is effective depth, and this resultant compressive force is acting at a depth of 0.42 XU. Now I want this distance, total distance D, this distance is 0.42 XU. I want this, means total minus, if you get minus this one, then you will get this Z. Yes. So lever arm Z equals to effective depth minus 0.42 XU. So this is the lever arm distance, D minus total D minus 0.42 XU. Now I got this distance. For what purpose I am finding this one? This, please keep it in dabba. This is also, please keep it in dabba. See here, my aim is to find out the moment of resistance of the beam. To find out the moment of resistance means I am applying a moment like this. If I am applying a moment like this, if you see at bottom, there is a resistance offering. There is a resistance offered by which one? My hand. What resistance is offering? It doesn't allow the moment. I am twisting this one. Twisting means I am applying a moment. If I am applying a moment, what happening means there is a resistance is offering. Resistance means it does not. Array, you don't allow. I don't want to allow you. Is nothing but this is the resistance offering. Here also, when the beam is stable, is nothing but when the loads are applying, the beam are still stable because of the resistance is offering. So how much that resistance is offering, that I want to determine. Tell me, what is moment? Moment equals to force into perpendicular distance. So in the strength of materials, we learned that force moment equals to force into perpendicular distance. If you see, this is one force, this is a lever arm, and also there is another force is also acting like this. This is compressive force, this is tensile force. So when the compressive force is acting this direction, when the tensile force is acting opposite direction, so what happens? So this is called compressive force. I want moment of resistance. Here two moment of resistance are developing. If you see, which how I can say, this is compressive force into perpendicular distance. What is this perpendicular distance? Z. Similarly, this is force. Which force? Tensile force. What is the perpendicular distance? This is the perpendicular distance. So there are two moment of resistance are developing. One is with respect to concrete, the second one is with respect to steel. Now with respect to concrete is nothing but what force we should use? Compressive force we should use. With respect to steel means which force we should use? Tensile force we should use. Now I am calculating. Now this compressive force is equals to this is perpendicular distance lever arm Z. Now I am finding the moment is nothing but this force into this perpendicular distance. So moment of resistance with respect to concrete, I am denoting with moment of resistance with respect to concrete. We know already moment equals to force into perpendicular distance. Which force? Compressive force into perpendicular distance is nothing but C into Z. Already we know that what is C? The total compressive force developed in that stress block is nothing but 0.36 FCK into BXU. What is lever arm depth? D minus 0.42 XU. So the total moment of resistance developed with respect to concrete is 0.36 FCK into BXU into D minus 0.42 XU. So put it in dabba. Next, same thing. Now we will apply with respect to steel. Concrete is over. Now with respect to steel, what force is acting with respect to steel? Tensile force T. This force into what is the perpendicular distance? This is the perpendicular distance. This force into this perpendicular distance. In the place of concrete is nothing but compressive force. Which force I should consider? Tensile force I should consider. But the lever arm is constant, same lever arm. So now this tensile force, the design's tensile force 0.87 Fy AST into the lever arm depth D minus 0.42 XU. The same thing. Array sir, why you are using two formulas? Which formula we should use? We are having a confusion. You are telling that moment of resistance with respect to concrete, moment of resistance with respect to steel. Both the formulas will give same answer, but based on the given data, we should choose which formula we should consider. For example, in the problem, they will give you area of steel, means number of bars they are considering, means then you should go for moment of resistance with respect to steel. For example, in the problem, they will give you the width and depth of the beam, other components, then you should go for the with respect to concrete. But any formula you should use, that ultimately they should give the moment of resistance is same. Okay. So this is the stress block parameters, very important. You should practice twice or thrice, not only university, even engineering services also repeatedly they are asking for 10 marks. Thank you.